welcome to the new course, which is electronics, which is the latest one. So what is this all about? Let's make a quick introduction to electronics, which is going to be unit 0. So when we hear the word electronics, the first thing that come to mind are televisions, laptops, cell phones, etc., any electronic device you can think of. However, these devices are not directly electronics, but they're actually electronic systems, and they're composed of sub-electronic circuits that we are going to analyze, and that's actually the main logic in this course. And actually they are having amplifiers, logic circuits, power supplies, etc., and again we are going to analyze, investigate such a circuit. Here's the thing, there has got to be a formal definition for electronics, right? If these devices are not electronics, and if you're saying that these devices are composed of electronic circuits, and how do we define electronics? So formally, electronics is defined as the motion of charges, and you know what charge means, in a gas or vacuum or semiconductor. So if you want, you can take notes. So I'm going to put that definition right here, and I will speed up the video. At this point, it is vital to note that motion of charge in a metal is actually not included in this definition because that's actually something different. So, by the way, this definition was much more meaningful in the 20th century. You know why? Because back then we had actually vacuum tubes. Now we are only interested, or not say only, but we are more interested into microelectronics that are circuits with transistors, and you definitely know about integrated circuits. We might also take a look at integrated circuits, but the first aim we have is checking out the discrete components we have in electronics. So a typical engineer is now able to perform many diverse functions to design, build systems actually that have some form of electronic. And that's the reason why we are all here today. Consequently, the division between an electrical engineer and also electronics engineer has become harder and harder to identify. And after this story introduction, let's talk about a couple of concepts that you should be familiar with. And by the way, about the story introduction, if you have any more questions, please be my guest and ask your questions. We are always here for you. So the first thing I need to mention before getting into anything is active and passive elements. So actually there is a really awkward and amazingly challenging definition for passive element, I guess. So actually I got it somewhere. Yes, I will read it. Let me put the title first: active and passive elements. So in the book, if you check out what a passive element is, there is actually this weird definition. I mean, it is not weird and it is totally true, but in order for simplicity, this is not the definition that I would go for. So the time average, all right, I'm reading the definition. The time average power delivered to the device over an infinite time period is always greater than or equal to 0 for passive elements. And this is, I think, confusing as heck. As an instructor, I mean, I'm not having any problems with understanding that that definition, but it is actually a little bit over the line. So what I'm going to say for a passive element is really simple. A passive element do not supply power to the circuit. Simple as that. And actually, the definition made, the formal definition made in the book is not wrong. It is totally correct, but it is actually taking a little bit of a time. So basically what I'm going to tell you is this: in circuit analysis, and I hope you have taken circuit analysis before this course because you are really going to need it. If you have not taken any course regarding circuit analysis, you can actually check our courses. We have 3 different courses on circuit analysis. The first one is DC circuit analysis, the second one is AC circuit analysis, and the third one is advanced circuit analysis, in which actually you're going to be able to solve any circuit you have. So basically in circuit analysis, let's say you have this element, right? And between the terminals, of course, we define a power P of t. If power P of t is negative, that means that particular power is supplied to the circuit by the element. But if that P of t is positive, that means the element actually is observing the power from the circuit. That's the logic we have. So passive elements absorb the power, they do not supply it. So basically I'm just going to say passive elements absorb the power, don't supply it, And in that sense, actually, we can simply say that P of t value for them is either 0 or positive. So P of t is going to be equal to or greater than 0 for passive elements, and that's actually what the formal definition says. And what about active elements? They don't absorb the power, they supply the power, and that's the reason their power variable, which is P of t, is going to be negative for them. P of t is going to be less than 0. This is the logic we have. And right at this point, we have a really valuable information for you. Transistors. You probably have heard this circuit elements before. Transistors are also considered to be active elements. And by the way, let me actually give you a couple of examples for passive elements like resistors, and also inductors in this class, and also capacitors. And at this point, sometimes I receive this question a lot. Let me put capacitors in here and tell you the question that I got. The question is this: capacitor and inductor, they are storage elements, so they're basically supplying power to the circuit. No, that's not it. So what we are needing at this point is for that particular element to supply a power that has never been created before by the circuit. But what capacitor and inductor does is simply this. They actually absorb the power from the circuit, and they actually supply it for a while. They store the power for a while, then actually they release the power. So that's actually not exactly the same concept with active and passive elements. So they're passive elements because they're not creating the energy or power from zero. But supply elements, like what? Like DC power supplies. Let me just say DC power supply. Also batteries. That's also a good example. And also AC generators. These are directly supplying power, which is not in the circuit, right? So that's the logic we have. And about the transistors, notice that I have not counted transistors as as an active element, and the reason for that is they do not supply the power directly. That's not what they did, but they're able to have an output which is greater than the received input. So actually the difference is crucial in here, because inductor and capacitor is also getting an input and they're storing that input, but exactly the same amount. If that capacitor is getting like 5 watts of a power, then it is later going to release a 5 watts of a power. It doesn't change. But the thing for a transistor is that if it gets a 5 amount of power, then it is actually going to have an output in an amount of 10. So that's the logic we have. I mean, it does not create power from zero, but it does actually have an amplification. And by the way, this whole thing, this phenomena, is called amplification for a transistor. So that's it about active and passive elements. Other than that, I want to inform you about discrete and integrated circuits. Let me draw a line in here. Throughout this course, we will be investigating circuits with discrete components. So what are those? Like resistors, also capacitors, inductors, transistors. These are all discrete components, etc., etc., etc. So they're actually the building block of ICs. And I think nearly all of you what IC stands for. It is integrated circuit. Basically, we're not going to be interested in integrated circuits. However, here's the thing. In the following lectures, we will take a look at some operational amplifiers. As you can understand from the name, they're having the responsibility of amplifying things. And operational amplifiers are a great example of ICs. So other than that, what we're going to do, basically, we're going to check out the discrete components in the electronic circuits. And also, another thing you should have, the necessary information, is the type of signals. Here what we have, the signals are actually divided into two groups. The first one is analog and the second one is digital. So as you can see, the figure 1 in here, it doesn't say figure 1, but I'm telling you, this is the figure 1. It represents an analog signal. It may vary continuously within the interval. As you can see, we are starting from 0, and let's say here we have the time t. Between 0 and t, our function may vary within the interval. It doesn't matter what value it has, actually. And notice that it is continuous, and this is pretty important. This is something that we're not going to have in digital signals. And the majority of the signals in real life we come across in daily life, by the way, are analog signals. That's also really important. For instance, in music, right, we have music signals. And everyone knows the cover of AM album by Arctic Monkeys, right? Which is this cover. And by the way, this signal we have right in here is an analog signal, so keep that in mind. Real life signals are generally analog signals. But what about digital signals? Here actually we have a great representation for a digital signal. It has two discrete values, logic 1 and logic 0, and this is actually what is happening in a digital signal. It generally has two discrete values. It is either one of them. All right, and electronic circuits that process digital signals are called digital circuits. And by the way, if your circuit is processing an analog signal, then it is an analog circuit. That's the simple logic we have. So finally, I will end this lecture by talking about the notations that I'm going to use. Here's the thing. I might have 4 different notations. So the first one is small letter and capital subscripts like this one or this one. The second one is capital letters and capital subscripts like this one. The third one is actually small letters and small subscripts. The fourth one is capital letters but small subscripts. But I actually break the order, so let me put it this way. So actually each of them has a special meaning, and I will explain you that in a minute. If you have a small letter and a capital subscript, that means you're working with total instantaneous values in DC. If you have capital letter and also capital subscript, that means you're having a DC value. And then if you're having a small letter and small subscript, that is actually going to be total instantaneous value in AC. And if you're having a capital letter and a small subscript, that means you're having a phasor value. So I hope I don't break these rules. I set them right now. I think I'm going to be able to actually apply these notation rules for the rest of the course, but if I ever make a mistake, just let me know. I will correct it right away. So this is actually enough introduction for electronics today. In the next lecture, we're going to talk about semiconductors, as they are highly important in our journey. So thank you for watching, and if you have any questions, please do not hesitate to ask. See you in the next one.